So these neurotransmitters transmit messages between neurons, but they also do it between neurons and muscles, right? So that's very important to understand that neurotransmitters in our minds usually is just between neurons, but there are synapses between the neuron and a muscle also, right? So your neurotransmitters are very important systems in that sense, right? Uh, they are formed either of amine molecules, amino acids, or neuropeptides, right? These are three different forms of chemical bonds that are there. Amino acids make protein, right? They synthesize proteins. Amine molecules are smaller parts of amino acids, and neuropeptides are forms of protein again, right? Neurotransmitters themselves can be of three types. So there are excitatory neurotransmitters. Excitatory meaning not that they engage exciting behavior, right? Excitatory meaning they increase a certain kind of behavior, right? So if you are happy and then you have dopamine secreting, it will increase your levels of happiness, right? But at the same time, if you are like feeling pain and dopamine releases, you might feel more pain because it's an excitatory form of neurotransmitter, right? An inhibitory neurotransmitter is one that reduces a particular kind of behavior. So if you are happy and then an inhibitory neurotransmitter secretes, say GABA, then you will become less happy, right? So inhibitory works in a good sense for pain. And then there are modulatory that manage between, right? Um, so an excitatory neurotransmitter promotes the generation of an electrical signal, which is an action potential, while an inhibitory prevents it, right? So it stops the generation. Now, whether a particular neurotransmitter is excitatory or inhibitory really depends on the type of neurotransmitter and the region that it's working in, right? We'll come to that. You'll understand that better in the next slide. Then there are neuromodulators. So most neurotransmitters, your excitatory and inhibitory neurotransmitters, are present between neurons, right, in their synaptic cleft. So between neurons or between neurons and muscles. So they'll only be able to work in that much space, right? However, neuromodulators are available throughout the entire fluid, right? The intestinal fluid, everywhere it is there, which means that they, at certain points where neurons may not secrete, they will come and they'll bind to the postsynaptic neuron, right? So they can affect a large number of neurons at the same time. They can create action potential, etc., at the same time, right? Um, Now these are neurotransmitters. Acetylcholine is an excitatory as well as an inhibitory neurotransmitter. So it does both the things. It can excite a behavior, it can increase the behavior, right? Or it can inhibit the behavior. Now, acetylcholine is usually present for muscular activity and memory. Very important, right? Linked with muscular activity, memory. It's excitatory for muscles that are skeletal muscles, whereas it's inhibitory for smooth muscles. So if acetylcholine releases near the heart, it will slow down the heart. Whereas if it releases for if you're doing a bicep, if you're picking up weights and all, right? If it releases there, then it will excite that muscle, right? It will increase the ascendancy, the pleasure that you're feeling from that, right? Whereas when it releases near the when it releases when it releases with respect to smooth muscles, it will slow everything down, right? It will try and reduce that. So if you get a cut or something like that, and your heartbeat starts to reduce or the pain starts to reduce, acetylcholine is working, right? For people with Alzheimer's, this is what is found that there's a reduced secretion of acetylcholine, right? Therefore, memory will start to dip. The affected areas are pons and the basal forebrain. So pons and basal forebrain are at the bottom part of your brain stem, right? Right at the start of your brain stem are pons and basal forebrain. Then you have norepinephrine. This is also an excitatory as well as an inhibitory neurotransmitter, right? Again, it depends on which site it works on. So adrenal glands, right? They release adrenaline, right? Adrenaline is an excitatory neurotransmitter, right? Adrenaline is a form of norepinephrine, right? Whereas sometimes it also releases as an inhibitory thing, right? So it's also linked with memory, but more it's linked with wakefulness, eating, right? And a general level of excitement in the body, right? Because again, just remember adrenaline is related to norepinephrine that will give you the connection that you need, right? Again, reduced amount of norepinephrine is linked to depression, stress, and panic disorders, right? Then you have serotonin. Again, serotonin is something we all know. Serotonin is again excitatory as well as inhibitory. It's linked with mood, sleep, eating, arousal. Serotonin is what works with people with depression, right? That's just if you keep that link in your head, you'll understand how it works. Because When you have depression medication, you are having serotonin, the reuptake inhibitor. So the reuptake stops, there's more serotonin, which means it's exciting the person a little bit longer, right? So if you remember serotonin linked with mood, you will remember that its main functionality is to do with people with depression, sleeping, eating disorders, OCD, etc. also. Serotonin is secreted in a place known as the RALPH nuclei, right? The spelling is wrong. It should be RALPHE, right? RALPH nuclei. Again, there are three excitatory as well as inhibitory neurotransmitters, right? So they do both the works. These neurotransmitters can be excitatory as well as inhibitory. What are the three? Remember it as ANS, that is like an answer, where the short form of answer. A for acetylcholine, N for norepinephrine, S for serotonin, right? So if you get a question saying which of the following are both excitatory and inhibitory neurotransmitters, right? If they give dopamine, histamine, serotonin, and something else, GABA, then you know it's serotonin, right? Because it fits in the ANS creation, right? Um, Next, we come to excitatory neurotransmitters, right? Histamine is an excitatory neurotransmitter. So this usually we don't teach this in college. Now, histamine is usually linked with inflammatory responses, your vasodilation, or regulation of your immune response to foreign bodies such as allergens. So when you get an allergy, suppose of your nose, if you get dust allergy, etc., right? That's lack of histamine, right? It's causing that problem. Histamine is not secreting. So when you have this Otrivin nasal spray that you all know, right? You see that ad, Otrivin, that's basically releasing histamine into your brain. So your nose and your brain is directly linked. There is nothing in between, right? Whereas for other sense organs, if you touch, it has to pass through your entire hand and go and then hit your brain, right? Whereas for your nose, it's directly linked with your brain. So when you press that Otrivin, basically you're putting in a lot of histamine inside, and that's releasing all the it's attaching to all the neurons in your brain, and that's releasing all the inflammation that is there because of the allergen, right? So it's an excitatory neurotransmitter. It's releasing things, right? It's increasing uh, the inflammation reduction, basically, right? Then you have dopamine, which is again excitatory. Dopamine, we all know, is linked with emotional arousal, movement. Just think of dopamine in terms of any drug in the world, right? That's related with what is known as the dopamine hypothesis, which is that if you take drugs, then it releases dopamine, and then that makes you get more addicted because it creates emotional arousal, positive emotional arousal, that is of happiness and excitement. But it's also linked with depression, Parkinson's disease, and schizophrenia, right? Parkinson's is basically the paralysis of bodily movement or muscle non-coordination, right? Um, so lack of dopamine does any of those three things. So if you want to remember this, just remember it as HDDH, whatever, right? Excitatory just to histamine, dopamine, right? Then you have two inhibitory neurotransmitters, that is GABA and endorphin. GABA is GABA bibutyric acid, some long name it has. Okay, just I don't know how to pronounce it, so I didn't put it, but you can just search for it. This is again linked with the motor system, so your bodily motor system, right? And then you have endorphin. This is related with pain transmission. So when you have a painkiller, basically what you're saying is you're secreting extra endorphin, which is releasing into your uh, synaptic transmission, and it's inhibiting the pain from moving forward, right? So action potential of pain is going through, and then when you have the painkiller, it releases endorphin, which does not let the pain action potential go through, but it binds with the next neurotransmitter to stop the pain, right? So inhibitory are E and G. Just think of it as example, right? That's endorphin and GABA, right? So totally, usually there'll be seven neurotransmitters that NET will ask you: acetylcholine, norepinephrine, and serotonin. These are your excitatory as well as inhibitory neurotransmitters. Then you have histamine and dopamine, which are both excitatory neurotransmitters. And then you have GABA and endorphin, which are both inhibitory neurotransmitters. Now you have neuromodulators that we spoke about, right? They're released in both your central and peripheral nervous system, and they affect multiple neurons. They work both excitatory and inhibitory, right? They usually work where neurotransmitters are not present, basically.